Hello, I'm Philip Stoughton. I'm on the Scoop Studio at Apex 2019. And I'm joined by three gentlemen to discuss the topic of using data over multiple sites. We've got Ranjan from Symmetrics, Oren from Mentor, a Siemens company, and Jason from Aegis. Thanks very much for joining me, guys. What I wanted to do today is not dig down in the weeds of how we get the data and kind of how we move the data around, but where we can get value out of it across a much bigger ecosystem. There are a lot of EMS players that have literally dozens of sites, some that are just 2 or 3, and I think there's a real additional value to be achieved by aggregating some of that data, maybe best in class, all kinds of different things. Ranjan, I know when we I've talked about this in the past. You've had some experience in the semiconductor industry where this has been done really successfully. Start by telling me a little bit about that.
So the main attribute of that is, as if you can connect all the equipment and get all the data, then you can start, if suppose you want to do OEE, then you can actually look at the bottleneck machines and collect that data and then do some analysis offline too. So the key to the whole attribute of this is you want, if some things are missing in the middle, then you can't really put the whole picture together, right? So in order to put the whole picture together, you get all the data, and now with the cloud analysis, you can actually store some aggregated results off-site, which can then be analyzed like a needle in the haystack. If 6 months later you have a problem, then you can go look at that. You don't need to store all the real-time data, but you can have some aggregated results that you can analyze.
Yeah. Oren, when you look at the companies you're working with, and now I guess you're working with a whole bunch of Siemens-owned manufacturing companies that are over multiple sites, what are they trying to achieve on an ecosystem level rather than on a factory level?
Yeah, well, I think, what you want to try to do is you want to try to, get away from, was that specific process not the best? Was there an environmental issue? As you scale up and you collect a lot of data from a lot of lines and a lot of different manufacturing sites, you can try and get some of that stuff away, and you can really start to look at patterns and anomalies. So we see a big trend, get all the data, aggregate it, and then let the data scientist hash through the data, try to find some root cause analysis. The other thing I see coming from our customers is they expect, us, Jason, these kind of people to come and provide them with some already insights, about what we've seen in other. So not everybody wants to, build a group of 5 data scientists and go through all the data. They want us to have already run some machine learning algorithms, have looked at the data, get their data collected, and then come and look for those same patterns that we have found in other cases. Yeah. So that's probably what a lot of customers are waiting for: aggregation, but then also the context, the processing, the process know-how. Because if you just look at the data in a very bare format, you can find a lot of things, but what does it mean? So if you can bring that process know-how and see what you've found in other places and look for it, you can really bring them a lot of.
Yeah, and Jason, you've always kind of had this vision of, I guess, what do we call it, the transparent factory, where you can see inside that. Growing that into a much bigger ecosystem should achieve more value. But you look at the EMS industry, and sites are full of legacy equipment. They're full of all kinds of different things. Is that achievable? And is AI one of the key tools to be able to do that?
Well, it is actually. Well, one, there's the connectivity, which we said we weren't going to talk about. So assuming the connectivity issue is taken care of, I find when we build out our enterprise hybrid cloud model for cross-site analytics, it was driven by customers, and I think both gentlemen alluded to it. The operations level people per site have very different analytic requirements and expectations than the C-suite does when they want to look across factories. I was actually dealing with a customer yesterday who is acquiring companies so quickly that their main concern is we need normalized multi-site data to determine whether we're getting ROI out of all these different sites we're adding. So it's things like that an operations level person or maybe manufacturing engineering would never care about. So you have to structure your analytics solution at that level in a very different way, in our opinion. That's more closer to the business analytics than it is to the process analytics, because that's what the multi-site one comes down to. But having said that, you're talking about a huge amount of sometimes unstructured data, and that's where the AI comes in. And there's BI tools, but then there are the ones that are coming that are really quite interesting, in that they can use AI to make massive amounts of data that without the data scientist. I agree, people don't want to have teams of data scientists. They want a tool that basically gives them the benefit of a data scientist team without having one. So yes.
Yeah, and just still with you, you work in a lot of different industries, not just in the electronic manufacturing space. Are there sectors that are doing this better?
I think there has been more of an awareness that cross-site analytics and the discrete manufacturing overall is important. The way it's been addressed has typically been through the IT department with custom solutions and big BI systems.
Right.
Having it inherent to your manufacturing operations management solution, I think, is something that's relatively new.
Yeah.
So but the awareness of the need, I think, was there before it was in this industry.
Yeah. Ranjan, when you look at it from your background in the semiconductor industry, it's kind of interesting in the software area in that it's invested massive amounts of money in their version of MES. You've seen instances where there are literally thousands of machines, tens of sites being connected. How successful has that been, and where has that added value?
So the key to that is like doing it at scale. So what they did is that they put it in the purchasing spec. These are the things that I want to collect. This is how I want to do this. And then they have a standard way to integrate it, and then a standard way to collect all the data and show it in a dashboard. So that's, I think, where they have the benefits is now they have moved all their effort from the bottom part of integrating the data to actually using the thing. To their factories are the most expensive, most sophisticated. They cost $12 billion. Each machine could be $200 million. So they don't want anything to be sitting. So you gotta get them all working for your product as soon as possible, and that's why each wafer, the 312-inch wafers, I mean, sometimes they would be worth more than a few $1 million each. So you want to collect all the data, and you don't have time to do all the analysis up front. So then you have to connect them at scale and then analyze them later, right? So they have put the infrastructure to do that together.
Yeah, and what can we learn from that? I mean, you mentioned the idea that in capital equipment or in CapEx purchase, it's already specified. It's almost like saying, I'm not going to take your machine unless it's got some protocol for collecting data. Is that something we need to see in this industry?
Yeah, I think so. I think it'll be good to have a way where it can be the vocabulary that this is like a keyboard in a computer, right? That you don't specify a particular keyboard, it comes with it. That's how I think it needs to be, where the connectivity and the ability to get data is an integral part of the personality of the machine.
Yeah.
Right?
Yeah.
So it is like a nose or a ear, and then you just have it. These are 5 senses that exist, and then once you put it in a line, you start collecting the stuff, interacting with the machine, and then doing what you need to do with it.
Yeah, that's really interesting, and I kind of look back at discussions we've had probably over the last 5 years, and I don't know how many times I've used the term Industry 4.0 ready or Smart Factory ready, and I am just amazed that there isn't a sticker that you can put on a machine. And again, I'm going to mention the word standards again, but to be actually able to say this is certified Smart Factory ready piece of equipment, that seems an ideal thing. Is that something that you think would make sense, Oren, and would make your life easier to know every machine was ready to be connected?
I think definitely. I think also what we see now, is there's a lot of issues around process control. So we see a lot of the machine vendors starting to, export data regarding nozzle pressure. They have much more sensors inside the machine. They're starting to output that. But many cases, this is not part of the, official standard. They dump it into some secret file. They have it in the machine. So when you start going into some of these more, interesting things, and you want to look at the correlation, and you want to see, for example, was the vacuum in the nozzle really attributed to some of the defects, you start seeing that, not all of the machines provide it. It's provided in a very different way. In some cases, it's some secret file where it's kept. And of course, that's making it very hard for us when you go to some of these manufacturers, which have a lot of different equipment, to standardize and really provide the same kind of visibility across all the lines. So definitely, if we could agree on all of the different data stuff that a machine needs to be done, and once it does that, it can get some kind of gold certification and say that it's ready for the smart world. That would be a big help. I would say, although, that I do have to comment, I think one of the biggest challenges we have these days with analytics is the cost of the hardware. we see in many cases that even if the machines are ready and the customer is willing to make the investment, once they see the amounts of data that need to be collected, and these SMT machines and inspection machines are really chunking out huge amounts of data, you want a 6 months, 12 months interval, and you start going to the 20, 30 terabytes of data, that's a lot of money on servers. In many cases, the engineering guys don't have a good enough proposal, and they go to the C-level, they get shut down.
Yeah.
So there is, we have to come with very, very articulated ROI scenarios that we can, empower them to show them how we're going to save the money so they can get budget. Because at the moment, I think that's one of the things that's stopping this from being deployed, is it's just expensive. These types of data are expensive.
Yeah, and Jason, that's that operations and IT collision that we've talked about numerous times. You've got to have budget for IT as well as ops. And yeah, I don't know whether the word collision is appropriate, but sometimes it feels that way.
It is. It's a good point. Data volume, now because we can get it, is storage and so forth. Even with cloud and Azure and whatnot, it's still a cost, right? And there are architectural ways of achieving it with stratified density of data that you're storing across different layers, but the problem then becomes those difficult decisions, and sometimes the customer doesn't feel comfortable with those decisions as to what data is going to be flattened and removed from the long-term storage. So it is becoming a complicated discussion. I agree that the data volume and what are we okay with losing, because if you start storing every image that comes out of an SPI machine that is happening across a 6-factory enterprise up in a singular server, you're going to wind up spending more on data storage than you are on the machines in your lines. But we're all engineers, and we love the fact that we might need that data someday, and it's a human thing, really.
It's interesting, and we just spoke recently with Jason from Selene. I interviewed him on a similar topic, I think probably a year ago, and he talked about an instance in terms of traceability where a customer came back to him and said, oh, we need the thermal profile for that group of boards. And the customer was delighted that he could give them a thermal profile per board, and that was really important. Just getting back to the Industry 4.0 ready machine thing, I kind of think of 4.0 ready as this idea that you can read, you can record, you can relay, and you can react. But I still think when I talk to people, there's a massive disparity on what even is defined as a smart factory or Industry 4.0 ready. Do you think that's part of the challenge in defining that in a machine?
Yeah, I think the attributes that you're looking for to collect and how you want to interact with the machine itself, that is a challenge, and the industry itself is very hardware oriented, so they are not that sophisticated to define it for each factory and each person. So the factory manager usually is looking some resources that can easily do that. In the semiconductor world, they had consortiums that did that, like Sematech. They all came together, different companies, and they defined, we'll have a reference implementation, then everybody copied that. Intel has a thing of copy exact, right? So I think that's what this industry would need, is somebody who's actually going to put together a reference implementation that can interact with any line, any machine, anything, and then you can get the data. And then every company needs to have a data officer that's going to define the data retention policies, data keeping policies. So they know actually when they get it, what they're going to do with it, how long they want to keep it, how they're going to have a hole in the firewall that their customers can see it. So those kind of things. So I think there's a whole level of a notch that will go up once this bottom layer becomes a given, right?
Yeah, and I think that's the important thing, and the whole idea of smart factory ready or Industry 4.0 ready as a defined thing is hugely valuable. I feel another subcommittee coming on in the IPC to do that. Jason's not volunteering, are you?
I probably will, but
you can't help yourself. But there you go, guys. Thanks very much for talking to me. I think it's really interesting to see where this whole ecosystem offering can go, and I think there are some challenges in terms of data volume and challenges in terms of connectivity, but I'm sure they can be overcome with the combined minds we have here. Thanks so much for your time. Thank you.
Thank you.